Hey everyone, and welcome to the fifth edition of the TestMu conference. I'm Devansh Bhardwaj, a senior product marketing manager here at TestMu AI, and I'll be your host for this session. Last year, this dynamic duo that I'm hosting for this session told us how developers were shipping code without writing it. But this year, the story is bigger than the individual developer. Across the organization, AI assisted development has stopped being just a productivity boost. It's changing how software gets imagined, built, tested, and shipped, and by whom. So the question on the table now is when software becomes everyone's job and who owns the quality? I'm joined with Kirti Devraj, who's a senior AI software engineer at Piramal Finance, who builds practical generative AI solutions for enterprise use across AI-assisted development, agentic workflows, and business-led app creation. On the other hand, I have Gurleen Kaur, who is also a senior AI software engineer at Piramal Finance, working on generative AI products and enterprise AI adoption, and has contributed to initiatives that change how business and technology teams collaborate. So please join me in welcoming Kirti Devraj and Gurleen Kaur.
Yeah. Hi, everyone. Thank you for tuning in. I'm just sharing my screen right away.
Just sorry to interrupt. Just a quick ask from everyone. Please feel free to post your takeaways and your learnings over LinkedIn and X. Tag us and use the hashtag TestMuConf so the rest of the community can also follow the conversation. And if you have any questions during or after the session, feel free to drop them in the Q&A box below. We will address them towards the end of the session. And just a reminder, in case you have to drop off mid-session due to any reason, you don't have to worry about that. This session, as well as all other TestMu conference sessions, are being recorded and they will be uploaded on our YouTube channel. So you better subscribe there so you can revisit them at any time and share them with your peers. Enough said. Now, Kirti and Tulin, the stage is yours. Thank you.
Thank you again for joining from across the world. And yeah, from wherever you're joining, try this. Think about your organization and count how many of the apps that are being shipped today, or how many of people outside the engineering team actually ship apps today. It's not going to be spreadsheets or dashboards with filters. It's actually software, live softwares. How many people do you think ship today? If you had asked me about Piramal last 2 years back, it would have been nearly zero. And today, the talk is about how this story became from zero to many. Like Devansh told, last year we had spoken about a topic, ship code without writing it. We had focused on how developers in Piramal are changing the way we code, basically from Jira tickets or any product management tools to taking it to GitHub PRs. How do we do it with our current systems in place and everything, right? What MCPs are we using? What skills are we using? And everything. And today, we are not going to talk about anything about what developers are doing or some might touch upon, but today we are mainly focusing about outside the engineering team, how AI at software development lifecycle has affected our whole organization.
So, when most of people hear about AI assisted development, we still think that we will go to VS Code and we'll have some extensions, or we will have our ID and we will ask Claude or client to write some code. That's where we started long back, like last year or last to last year. But that's not longer the story. Then there are 4 points to our story. Today, AI is touching the entire journey of software. It helps us imagine what to build. It helps us to build it, then validate it, then it helps us to ship it. But there is a much more interesting shift. It's not just about AI. What is AI doing? It's about who is able to do it. The person with the idea doesn't necessarily to be waiting for an engineer or a coder to code it for you. The boundary between business, product, engineering, and operations has started to become blur. AI stopped being just a developer tool. It has started becoming a software creation layer itself. So the question is how we get there. Did we get there, like did we created something and now everybody can use it? Or we are still in the code. So we need their work faster. So initially they had their IDE, how I discussed earlier, and then they had their Klein or Claude, and then engineer used AI, and then they used to code. So the routine implementation collapsed from hours to minutes. So what we had done was we had made engineering faster, but the rest of the application, but rest of the organization was still moving at a very slow speed. So now we wanted to make, so let's say if I'm riding a car, even though I have so much speed, but what if there is traffic outside? I cannot go still. So I have to make something, so I have to remove the bottleneck. So once we realized that the bottleneck wasn't just coding, we changed the model. So the driver isn't slow, as I discussed, because they can't drive because of the traffic. So what we thought was, now how can business build this requirement rather than engineers going forward and doing it? Can we initially, what was it, requirement, then meeting, then sprint, then deployments, testings. But then we thought, give us requirement as a developer. So you give a team requirement and we will get it delivered between 2 days itself. So the months became hours, and then something interesting happens. We saw there was some possibility of, what if we give this responsibility also to business? Why do I need to even ask engineering every time to develop applications? So that's where BYOT came. So this is the strongest transition in my story actually. Tatkal proved that AI could dramatically compress software delivery, but BYOT asked a much bigger question. What if we did not even need engineering to build every tool? So what we enabled was, earlier what was happening was business, then engineering, and then product came. But what we enabled was business, then platform, and then application. And now all the business teams can suddenly code. So this is what BYOT was. Then there was one more shift where we introduced KriyaOS. Now when everybody can build, there are a lot of other bottlenecks. So if I have to see from my end, what if I have to take it to production? What if I have to do an RC on it? What I have to see, that what are the errors in the application? So all this was solved by KriyaOS. Going forward, we will get deep into understanding how KriyaOS help. So this is the shift which we moved from AI in from
Okay. So basically, just getting back on what Gurleen was telling, how we started, or this is our chapter one or phase one of our whole journey for the past 3 years, right? So we did definitely 2 years ago, we started our AI DLC journey, or AI for software development lifecycle journey, where we started introducing Klein, a tool that we saw at that time was amazing, and is being used today also in our organization by engineers. This was really working with, at that time, I think we launched it with Cloud Sonnet 3.5, I assume. So this was good. We rolled out to the whole organization. It took about a full engineering organization, and it took about 6 months to do this. And we started seeing impact over there. Like everything that was costing for months started becoming weeks. Weeks started becoming days. Then people started watching this outside engineering and started asking this question: if AI is writing the code, shouldn't tech cost much lesser? In our case, it was a matter of even time. Okay. So that's when we thought we need to solve this a little differently. And we might need to start a new experiment squad called as Tatkal. For people who are not aware of the word Tatkal, Tatkal is basically, in India, we use it for one day before getting train tickets, a day before. It's like an immediate ticket or urgent ticket where you pay some extra amount. Okay. So we just, Tatkal, basically the word means immediate. So we thought any feature you give us, we'll deliver it in 48 hours in production. These are definitely not high skill, or I would say high complex systems, but any normal systems that would require CRUD operations with a few integrations, that's definitely possible. Then this was set up. Delivery definitely went to hours from months. Business was really happy. But then they were too happy that They used to come to Tatkal squad always, and it became the most in-demand team in the organization. This started becoming an anti-pattern also. So that's when we realized the problem was not with just delivery. Demand for the software was also increasing infinite. So when you give options, there's going to be always demand that is for software. So delivery was again becoming a bottleneck for us. It is not about the time of development, but the amount of apps we could shift or uh, catering to the demand of business. So parallelly, people started asking one more question. If AI is doing the typing, why do engineers actually matter, or where do we need to put engineers upon? So we started thinking about use cases. For example, we started thinking about a use case where, let's say, there are frontline staff in Piramal Finance who are taking care of the sales of loans and everything. So if they need to give daily reporting to their managers, it is in a very informal communication, like in Teams or in a call or something, or message on WhatsApp or something. What if we need to make it a little formal? What if we need to create a portal where they just enter and manager is seeing able to see everyone's their reportees, reports and everything on daily basis. This is a very simple CRUD operation. Do you really need engineers to solve this? And on a daily basis, maximum of 5,000 people are going to report. Do you really need engineers to solve this? Maybe not. But if you think about a core system where loans are getting processed and there is compliance related stuff and there is some data security related stuff, engineers are definitely needed. So we started thinking about this question and bifurcating of where engineers are required, where we are not required. And that raised a question: what if people who need the tool build the tool?
So this is where the story actually got really interesting for us also. So up till this point, how Kirti mentioned, we have been making engineering faster, but then there was still a fundamental model that hadn't changed. The business had an idea, they wrote a requirement, and then they waited for someone else to turn the requirement into software. And then we started asking ourselves why? Why is this even required? If AI had made software creation this easier, why shouldn't the ability to create software sit with us only as engineers? That's where BYOT came from, where which we name as build your own tech. The idea was simple. Instead of business telling technology or us to what to build, give business the ability to build. Give them the capability. BYOT is Piramal's platform. It is a platform made by engineers itself where business teams can build and ship their own internal tools. So, this isn't about giving everyone access to production systems, you might be thinking, and saying, like, go and code. It's about creating a controlled platform where someone who understands the business problem can actually turn that problem into a working application. So our first instinct was actually pretty obvious. If we want business team to build software, let's teach them to become developers. That's what we think, right? We explain them what is front end, what is back end, what is API. We tried that actually. We went to business people. We took their laptops. We put Node.js in their laptops. We gave them access to client, and surprisingly, which we thought about, it actually worked. The apps they built were not just games or snake and ladders kind of demos. They were actually good things. They understood the business better than what we could, and they, because they are the people closest to the business, so they actually created the solutions which were solving a lot of problems. So till here we had solved the first problem, which was building. But then there was a realization for us also. We hit the wall that how will they deploy this app? Where will this app run? Who will own the API? And who will manage secrets? Then how will monitoring happen? So we taught the business how to build software, but we have not taught the organization how to ship the software, which is built by business. Building actually worked till then, but shipping till that time was impossible. Then we look back at what actually gone wrong. Like there were a lot of things which we also wanted them to do, which was deployment, security, how I discussed about. Then there was if you think about the port 3000, which is always occupied because everyone is developing. Then app moved to 3001, then it moved to 3002, and then it moved to 3003. So none of these, if you read any one of it, which is hardware compliance, these are not coding problems. These are platform problems. So we then went back to our first principles. If the business can already build this much good applications, why do they need to learn these many things? Why do they need to learn deployment? Why do they need to learn hardware? They shouldn't. So then comes the idea where we built the platform that takes care of everything. And what's interesting is that we started this kind of 2 years ago, before actually AI app builders had really become a mainstream category. The first thing which we removed was setup. So what we did was we put VS Code in the browser. No node installations, no dependency hells. So they do not have to worry that if they could react, they would be able to run React or Node. So we removed the layer in between where they had to know all these things. So what they actually need to know is they need to just chat with the platform, then install whatever is already there in the platform. So after they have everything sorted out, they just have to click on one button and they go live. But this does not mean that we are removing engineering from anywhere. Underneath that, there was everything pre wired. All the engineering capabilities, which is authentication, DBs, which is ports, secrets, we have done that in the platform itself. And importantly, that's what the major thing is, we are not removing any engineering standards. We just put guardrails into the platform itself. So the person who's building does not have to know what is the rules which the platform is already following. And then something surprisingly happened actually. We actually never realized that this will become so big. We had built BYOT because we actually believed business teams could build software if we remove the technical friction. But we didn't know these numbers will actually come to the picture. Today we have 947 builders across our organization, and they have created 1306 projects. Amongst them, 370 apps are live in production, and they are not just prototypes, no hackathon demos or any small applications. They are live applications which people are using. And that's the part I think is most important. These applications were built by business. They are not operated outside technology. They are still governed by engineering. Business gets it's just we are giving them the capability to create things. Engineering still retains the ability to govern. The separation is separation between what BYOT users will do and what engineering will do has actually made BYOT scalable for us.
And now comes KriyaOS, right? We saw BYOT becoming big success, and close to 1,000 people are already using it in the organization, and which is really great. But is building the only part, and is deployment the only part? But our software development life cycle is still a big thing, right? We do have each phase that we have in our engineering practices that has been there for a reason. So we thought, why can't we try to embed everything in a system? So that's when KriyaOS as a system started coming in. So that's basically an operating system for software creation. That's what we wanted to envision it as. So BYOT definitely solved the problem of building, but here we have requirements, designs, sign-offs, UAT, how UAT happens, deployments, post-deployment monitoring. That was never spoken in the previous slides or never covered, right? That was always a engineering team's headache only. So how can we solve all these together in the same journey where again engineering teams dependency is reduced, people can do things on their own? That was KriyaOS's vision, and everything's to be operated by AI. If you take a look at this loop, right, when a requirement comes, we have a concept of shape node creations that happens. This happens in Piramal even for our engineering projects right now. So shape note is a one-pager document, a illustration that we create based on a meeting or a transcript that we are having, or a just a ideation. You just talk about the idea, and a shape note one-pager is getting created of what are the workflows that are going to come, what is exactly going to be in that. That's a requirement doc, ideally. Okay, illustrated a requirement doc. Once that is approved, then comes the step of mockups creation, like how our design teams used to do that. Similar way, here AI is involved, mockups are getting created. Once the mockups are ready, then comes the building phase. And once you have built, it doesn't end over there. You spin up an ephemeral link, give it for UAT. UAT feedbacks come in, it comes in as tickets inside KriyaOS platform. Like how you have Jira tickets or something, right? KriyaOS also has a way to get in feedback as tickets and everything. And the builder can just click on a button called fix and it's going to be getting fixed. We'll see a little detail how it happens. And once you deploy, again, an RCA agent is keep on seeing how your performance is there. And if there are any issues, again, tickets are getting created. Once you click on fix tickets, it's again going to go into the same loop of deployment and fixing and everything. So let's take an example. A business user is coming up to the platform and asking, expense claims for my team keeps drowning in email. Build a tracker with an approval workflow. And you send this. You don't go to building again over here. You're first taken to a shape note page, okay, where some illustrations are happening. This is just a representation of that. Once what all workflows are going to be there, what all is your ideas that you have, what all I'm planning to implement as AI. From AI's perspective, what am I going to implement? All these is going to come over here in the illustration. And once this is there, approved, then mockups come. Like we say, once it is approved, that's when building starts. In previous steps, across our previous steps, it was always building first. And when we do that, there is chances that building is going to work perfectly fine. But there are also chances that it is going to go start going in iteration loops continuously for people. And let's say they want to change a component in a page, that is going to take them so much tokens, which is going to incur us cost also. So to get rid of these, we try to build some shift left concept where we are basically like until we agree on the idea, there is no code that is being written. So when we shift left, our cost is also getting reduced. We are also like funneling down the whole system, and now it is in a much better state. Whatever output that is getting generated by AI. Again, if you have some ideas, you can choose to go the same route also. And this definitely improves our quality of development and the apps also. And once you launch something for UAT, here again, it is not going to be a simple UAT like you share the link and you get it back in chat or something, like in of the platform or something. So when you're sharing, it's going to be a KriyaOS link only. On the right side, you have the app running. On the left side, you have a chat interface. You keep noting down what all issues you are going to have. For example, can we add a GST field on the invoice form? A ticket gets created automatically in the platform's project directory. And when a builder is coming, when the actual builder or the owner of the application is coming, they have a button called fix. They can just click on fix and it's going to again send back to the person who has raised the issue once it's fixed. So the similar way for RC also, it keeps checking like 4xx, 5xx, is there some issue going on? Am I seeing error logs? And once everything happens, again the fix ticket is raised and there is one click button that is available for fixing. Okay.
So everyone would have seen now what is KriyaOS, what is BYOT. So you might be thinking that if everything is done by business, they are coding also. What as engineers we are doing? So what are you doing in your organization? That's what you wouldn't be thinking about. So here, engineering actually did not go away. Engineering just moved a layer up. Instead of spending our time repeatedly solving the same problems in the applications, we started thinking about the solutions which can be reused by entire organizations. So first, we created the Piramal Skills repository. So we encoded roughly 30 skills. So whenever you start coding in your ID or anything, you create a skill.md file, right? So based on what our best practices are, what our as pyramidal standards are, what our patterns are, we created some skill set. So now instead of every AI session starting from scratch and a blank page, now AI will always have a pyramidal way of thinking and building softwares. Then we also integrated MCPs. So we connected AI to actual tool we need for monitoring, for deployments, for project managements, and for designing systems. So AI isn't just generating code here; it is actually operating in our engineering environment. Then we had our API catalog. So our internal APIs become available as MCP tools. For an example, if you are using Jira, so you just expose it using an MCP, so that your now KriyaOS knows it how to use Jira, but the business user does not has to know what it is doing at the background. Is it creating a RCA ticket, or how is it using that ticket? So we just creates an API catalog. That means when a business application needs something which already exists in Piramal, we are not doing it all over again. So the effort is reduced. And finally, we created starter kits and secure defaults. Engineering decide how someone is going to get authenticated, how are we going to keep secrets, and how are we going to work on apports. And then these decisions are automatically inherited by everyone who are building softwares using these platforms. So this is the key shift here. Engineering used to solve these problems earlier by application to application. Now engineering solves them at once itself, and the platform is distributed as a solution everywhere. That's what we call it as Piramal AI DLC, where less code is being written by the hand, but there is actually more engineering than we were doing before. Because engineering has moved from just writing every implementation or designing the systems to creating a reusable component which can impact thousands of users at once. So, if you would have heard what I said earlier, which was AIDLC, we have solved one side of the equations, that we can now build softwares very fast. But now there has been a new problem. If softwares are created in hours, we can't afford time for quality checks, because otherwise we are just moving the bottleneck from one problem to the another. So the next thing which we thought of building and we are building is QIAIDLC, which is quality as a software development lifecycle, how we were doing AIDLC. The idea is simple here. Every application should get its own testing lifecycle automatically, be it integration test, be it regression test, or smoke test. Not because a developer remembered to write them. The same way AIDLC generates and standardize code, QADLC generates and standardize quality, and then we make it a mandatory CI gate. So it's not like someone is giving you a suggestion and if you skip it, you can move forward. Quality for us is a wall, it's not a suggestion. If an application does not pass that wall, you can't ship it. We don't want a human which is sitting and waiting. So let's say if something failed in your pipeline, we can't wait for a human to check it and then solve it. If a test fails, the system itself raises a ticket, identifies the problem, then attempts the fix, and then run the test again. So now the flow or the cycle becomes like, we first build the application, then we test it using QADLC. If it fails, we at the background raise ticket, we fix it, then we test it again, and then we ship it. So the same loop that AI has created for writing code, now we need to do it for the quality. So code already ships at AI speed till AI DLC. Now quality has to run on the same loop. So KriyaOS also has these already embedded into it, be it AI DLC or QA DLC. So here is the obvious question which we were discussing earlier also. So now what where did the engineers go? Because if like business teams are now building applications, now we have already also done the QA part. So the answer is engineering got more important things to do. As engineers, we are now not just developing individual applications, we are creating platforms which 947 builders, you saw the numbers, right? So for them to use, we have to move a layer up. We have to create platforms which are stable and scalable for them to use. So instead of building one application for everybody, we are building BYOT, we have worked on Kriya, then we worked on AIDLC, then came QIDLC system that allow everyone else to build better and faster. The rest of the engineering moved towards a problem that doesn't disappear just because AI got better at writing code. We still work on our core systems, scalability, security, our data. The problem where architecture actually matters, where reliability matters. So those are the exact areas that were still competing with the routine work of engineering attention. So yeah, you can take forward.
Yeah, so definitely we did learn a lot throughout our journey. There were surprises. There were things that went really well. A lot of things did go really well. There were some things which did not go really well, and we eventually, over time, overcame those by creating better solutions and understanding the problems and everything much better. Right? So we'll just take a look at this numbers that we discussed about BYOT, right? 1,306 projects were created on the platform. That was true. But if you had noticed, only 369 apps actually went live. What happened to the rest of the apps? Like 937 apps, if you do the math. Let's say even 200 apps are in progress and yet to be launched. Let's say we give that as a reasoning. About 700 apps are still pending, right? Where did these apps really go? Like with people, so many people coming in over here, like we do run workshops on how to use the platform, how do you do good practices, bad practices within the platform, how do you interact with AI. All these workshops are being run. When people are using it for the first time, there are going to be experiments, there are going to be duplicate projects that are getting created, there are going to be practice runs they are going to get done. All these are going to cost us a lot of money, because eventually they will use resources, eventually they will use AI, which is eventually going to cost us tokens, and this is going to be thousands of dollars. Where you would actually see this value and where we saw the value is, let's take an example of a collections business users from the collections team. So eventually what they were doing is like, they got introduced to the platform, they did first app, they were not so happy. It was a trial, they scraped it out. They did the second app, again they were not so happy, they scraped it out. They did not see the outcome. But all these, the first two, right? They had some learnings. With that, they built the third app, which was an automation related stuff, where they used to have 1 month activity. They were able to reduce, after building that, let's say they spent 20 days to build it or 30 days to build it, and after that they actually reduced one of the activities they used to do in their regular days from 30 days to 5 minutes, which was a huge impact for the organization. And that was one of the extreme cases, definitely. But think about like at least 20% or 30% improvements, and think about audit improvements by digitization of a lot of things. And definitely those things yielded up more value than the cost that we see over here that we spent for 700 apps. That gap was definitely real money, but the learning plus the outcomes that we saw, if you multiply it with 369 apps that are live, that would be humongous benefit that we have seen in the organization. The next thing was like, mainly I would say, let's say Piramal has close to 20,000 people associated with it. Let's say even 1/10 of them had ideas a quarter, one idea a quarter. That is close to 2,000 ideas. In a year would be close to 8,000 ideas. On a best scale, we'll take 5,000 ideas are there for the organization. But if we have a lean tech team or a good amount of tech team, but let's say there is a use case around, somebody comes up with an idea and says, like, I need this app to be developed by the tech team, and it will impact two people in the organization, and this is going to save half our week, and we can use that time elsewhere. This is very impactful for that person and the other person in the team, but is it very impactful for the whole organization? Might not be. So it might not get prioritized also. So small ideas start dying. Now, because of these platforms being there, automatically the long tail of backlogs and the full ideas are getting built by itself. So the dependency on the tech team has reduced drastically. Because of this, like lot of productivity apps, automations, integration, digitizations, everything is coming to light and being built without tech team.
So I'm going to give you a real life example here. We actually had a collection team which was using a follow up tracker. So it was live. People also were loving it, and then they had just a small request that can we upload the customer name list, and it automatically sends WhatsApp reminders to the customers. So with AI developing, the part was really easy. So AI drafted the feature in minutes, but then it tried something interesting. It reached for a third party messaging API, and it couldn't. Not because someone was actually reviewing the code, let's say engineer like me, I was reviewing and I checked that there was a third party call. No, it was not the case. Not also because there was a security scanner at the background. There was nothing like that. It was because the platform which we developed was simply not allowing it. So applications on BYOT, or let's say KriyaOS, can only call services exposed through our approved API catalog. It cannot just go ahead and do anything and everything. So the dangerous path doesn't exist. That's what we mean when we say it is closed by the design and not by the luck. But here's the important part: the platform prevented the technical risk, it didn't make the business decisions for us. So this platform majorly will not allow anything which is risky for us, because there has been some checks which we have at the background, but the decision stays with us still. We still had to ask, should customer contact data should be used to automatically message customers? What consent do we have? When should we do the message? What should the tone of message be? So these all questions are still not answered by AI. Then we rebuilt it using approved internal communication gateway from the API catalog. The application went live the same week because it was approved in our system. So the outcome wasn't security blocked feature. Security here helped us shape the feature. And it also helped us to not overcomplicate our use cases. So now that we have talked a lot about BYOT, Tatkal, and KriyaOS, we have talked a lot about AI, what it can do, but what it can build. It can also test, it can deploy. But there are things which we deliberately do not want AI to automate, because speed isn't the same thing as judgment as what human can do. The first thing is deciding what to build and why to build. AI can help us explore solutions. It shouldn't decide which customer problem is worth solving. The second is our boundaries. There are a lot of security things, data, compliance. The platform can enforce these rules, but deciding what should be the policies, what should, uh, so let's say if I have some security policies, but deciding on to what are those policies still stays by me. Third, the core platforms and the complex systems. AI can write a lot of code. That does not mean it can architect. It knows what are the trade-offs and what will be the long-term system design also for our organization. So knowing when something technically works out but shouldn't ship, knowing when to say no, that is something which AI does not know. So if the judgment stayed with human, what changed? You'll say that it always was with human. Quality, the shift of quality came earlier itself. We don't wait until the end of development to ask if something is good or not. Quality starts with the requirement itself. If you remember what was explaining earlier, we use something known as shape note. So it gets encoded into our prompts itself, into our workflows itself. Test cases are also defined before the application even built, and the review happens throughout the loop in building itself. So the philosophy has changed from building fast and check later to build with quality embedded from the beginning itself. So far, BYOT has changed where the software gets built. Business teams can now build systems. They are connect. So now, what the business problem here for us was, now they can build a lot of standalone apps. But the core systems, for an example, if we have a credit workspace, if they want to build something in the core system itself, how will we do that? Imagine a business team sees an opportunity to improve a workflow. Today, the natural answer is raise a requirement, send it to us, we will modify the core platform. That's the boundary which we are trying to remove. That line we want to blur. We want business team to be able to extend the experiment, these all experiences in the core systems itself without actually changing the core system. So what we have done is but what we have developed a system where they can go ahead and change the core system, but it wouldn't affect any other things which is already shipped. So what we are moving from building alongside with code to building within the code, and that's where it gets really interesting, because one software can be safely extended and used by the people where the business people know what the actual problem is, because they are closest to the problem. So now
Hi,
I can say,
Gurleen. Hi, Kirti. So sorry to interrupt. Just want to let you guys know that we're left with 5 minutes for the session. So yeah, just a heads up.
so now what we have already shown you and talked about, there is one thing which we learned throughout the process. There is no shortcut to these things. You can build the best platform in the world, but the first thing which you have to change is someone's belief system about what they are capable of. When you tell someone from business that you can build an application by yourself, the first reaction is always they do not believe it itself. It's a disbelief, because they have spent their entire career thinking that it is something which engineers will build, right? We actually did not started by saying that here's the platform, go and build. No, we started with tiny applications, something that actually solved a very tiny real life problem, then with another, then another. So it happened with small application. Every successful app, when someone was able to build, they changed their mental model. They started believing that this could actually happen. They could actually code, and eventually these small applications help building the confidence. That's why even knowing what we know today, we wouldn't skip how we started. We'll still start with how we will first let people believe they can do it. So. So the lastly, I'll say that you can't install a mindset. You grow it actually. So it will happen by one app, then another app, then another app. You can't do it in a day. You have to bring that shift in the mindset. So yeah.
So one of the things that we have seen across is like definitely AI assisted development is not just about development or just building. It's about all the four things that all the four pillars or something. Imagined, built, validated, and delivered or deployed.
So how we mentioned, right? Business teams are now becoming builders, more of like engineers, not just giving PRDs to engineers. So yeah.
Engineers again are not getting replaced. Their role shifts to more complex stuff. Building platforms, guardrails, validations, and building something that can scale to the amount that we want, right?
So now, how we discussed, right? It has not, because the speed is increasing. That does not mean we will check later what has happened. After I ship the code, I cannot sit and see what are the incidents which were caused by AI. So we have to move quality earlier itself. While I'm taking the requirements itself, I have to think about that mindset. So I have to think about what are the requirements and what am I going to inhibit in my platform itself, which is going to think about the quality itself. So I'll say thank you, thank you, Devansh, for inviting us here.
Thank you everyone for joining.
Thank you for
Really.
such an insightful session. We don't have much time, but I would surely take a few questions. Just a second. Okay, so the first question is by Paul, and he's asking if software is everyone's job, and by extension, agentic AI is the way to update, manage, and engage with it. What's the best way to prevent shadow AI or misuse of the AI tools in the software workflow?
I think, like, if I may take this, like, it is about the guardrails that you build. Like, for example, if you're choosing an agentic AI software or the tool that you're choosing, but along with that, what are the guardrails that you're going to have? Let's say you try to use Cloud Code today with basic accounts that you're having with the general availability models that Cloud Code is given. They have some guardrails that even an authentication system, Cloud cannot log in on its own. So obviously there is some guardrails that they are also setting. There is these things for a reason. So I think whatever we are building, I think we build with guardrails that prevent us from any misuse or anything. For example, we are having related to secrets, deployments, how authentication happens. All these are not coded by business. All these are already pre-built in any app that is started for building. So I think that you
Add,
can.
adding to it, there are different level of guardrails. We still know what all access as an engineer I have. If you're from HR team, you have different access than me. So this will prevent shadowware. You'll have some RBAC systems. You will know what are you providing. So these are all guardrails step by step. So yeah, I think that's all about it.
All right, perfect. Apologies to everyone because we are short on time. I might not be able to take any more questions right now, but do not worry about that. You can definitely reach out to us through our support, or you could comment on the recording that will be going live over our YouTube channel. Once again, thank you so much, Kirti and Gurleen, for such an amazing session. And yeah, everyone watching, I hope you all enjoyed the session. And yeah, see you guys in the next session. Thank you so much.
Thank
Thank
you.
you.
Bye.
Thank you. Bye.